Python functions are essential building blocks that allow us to create modular, reusable, and organized code. In this section, we will cover a comprehensive range of function concepts such as basic function definition, how to create simple functions and execute a specific task, function with default parameters, making the functions more flexible with optional values, function with return values, getting results back from the functions, lambda functions, creating compact anonymous functions for simple operations, and multiple return values, how Python functions can return several values at once, and docstrings, the proper way to document the functions for better readability, the scope, the understanding the visibility of variables within the functions, and built-in functions, user-defined functions, and function annotations, and higher-order functions. Python functions are blocks of reusable code designed to perform specific tasks. They allow us to group statements that work together to accomplish something useful, making our program more organized and maintainable. By defining the function once and calling it whenever needed, we eliminate the repetition and make our code more efficient. Let's look at why functions are so valuable in programming. Functions increase code readability by breaking down complex operations into well-named logical units that clearly express their purpose. They also improve the code reusability, letting to write a solution once and use it throughout the program or even across different programs. The syntax of a function begins with the keyword def followed by the function name and the parentheses which may contain the parameters. The function body is intended to contain the code that will execute when the function is called. Optionally, we can use the return statement to send a value back to the caller when the function completes. Python offers two main categories of functions. First one, the built-in library functions are predefined in Python and ready to use right away. For example, print function, len function, range function. And the user-defined functions are custom functions that you will create to meet the specific requirements of the program. These give you the flexibility to extend the Python's capability in the way that suits the particular needs. Here we have a simple greet function that takes a name parameter and returns a greeting string using f-string formatting. When we call the greet with the argument Python, it outputs hello Python, demonstrating how Python function works. Next we have a function with default parameters. We have modified our greet function to have world as the default value for the name parameter. This means that if we call a function without providing an argument, it automatically uses the world instead. Next we have a function that returns a numerical value. This add function takes two parameters and returns their sum. The return statement specifies what value the function should produce when called. We call add function of 5, 3. It calculates 5 plus 3 and returns 8. Next, the lambda functions are the small anonymous functions defined with lambda keyword. They can take any number of arguments but contain only a single expression. Here we have defined a lambda function that squares its input and assign it to the variable square. When we call the square of 4, it returns 16, showing how lambda functions provide a concise way to create simple functions. Next we have the functions with multiple return values. In this example, getCoordinates returns a tuple containing two values. We can then unpack these values into separate variables using multiple assignment. When we call the function and unpack the result to x and y, we get the values 10 and 20, demonstrating how functions can return multiple values at once. Next we have the docstrings. They are used to document the functions in Python. They appear as the triple quote string immediately after the function definition. This multiply function includes a docstring explaining what the function does. The docstring helps the developers to understand how to use the functions. They are accessible throughout the help function or IDE tooltips. Python has specific rules about the variable scope. Here we see a global variable x with value 5. Inside the local scope function, we define a local variable also named x with value 10. When the function is called, it prints the local value 10. After the function completes, when we print the x again, we get the global value 5, showing how local variables exist only within their function. Function annotations provide hint about the parameter and return types. Here we annotate x as an integer, y as a float, and specify that function returns a float. Annotations don't enforce types, they are just hints and help to document the code, and you can be used by type checking tools. Next, the higher order functions either takes function as the arguments or return function as the result. Here, apply function takes both a function and a values as a parameter. It then applies the provided function to the value and return the result. We when call apply function with our square function and the value 5, it returns 25, demonstrating how functions can be passed around and used like other values in Python. A decorator function is an example of higher order function. In this section, we have covered everything from the basic definitions to advanced concepts like higher order functions and annotations in Python.